Okay, so welcome to the Game of Stones, the magic of metallurgy. This is our discussion session, and we're going to be talking through some of the ideas about ancient metallurgy, thinking about the ways in which people have used metal in the past, and building on the sort of things which you might have seen in some of our videos if you've had a chance to watch them. If you haven't yet, don't worry. Just hang around, have a listen to what we're talking about, and then maybe watch them afterwards and see what you think. If you have any questions at any stage, just shout out, and we'll try and answer them. We'll sort of look at them on the chat here. You can also ask questions directly to my email if you email me with the subject line LightNight20, so I can find you. Then you can ask questions there as well. If you ask questions at any time, we'll try and get to them when we can. Anyway, so I'm Dr. Pete Hommel. I'm a lecturer in Archaeomaterials at the University of Liverpool. And I'm here with some of my colleagues, Dr. Matthew Ponting, who's the senior lecturer in Archaeomaterials at Liverpool, Dr. Alan Williams, a former student, and two of our PhD students, Jake Morley-Stone and Liz Thomas. And we're all working on various aspects of metallurgy and the study of ancient metals and the way in which they sort of fit into society. We're thinking about everything from the way in which metals have emerged and spread in the early periods of their use, through to the uses of various forms of coinage into the sort of more recent and sort of Iron Age and the Roman period. So we've got lots of a broad kind of spectrum. But we wanted to start by sort of maybe having a little chat about the way metal starts. And it's something which people have talked about for a very long time. Matthew, you've been working in metallurgy for many years now. What's the story? How have things changed over the time? What's the sort of thinking about the way it's developed?
Well, I suppose the main change in the study of archaeometallurgy has been an increase in the amount of data available to enable us to model what we think might have happened and to estimate the sort of trajectory that human knowledge went in. I think one of the things that is becoming increasingly clear is the very strong link between the origins of metallurgy and an important change in human society bound up with the development of a more settled agricultural life. And this is the development of a feeling to decorate oneself, personal adornment. And I think this is very strongly attested in the archaeological record by the appearance of items of personal adornment in the Neolithic period, especially things like beads. And very often these beads are made from brightly colored rocks and minerals, things like green malachite or various ochre minerals. And of course, alongside that, we have the very impressive phenomenon of cave paintings, the use of ground pigments like ochres, which have been used to create some of these wonderful illustrations that we see. So the growth of this desire for pretty things led to people searching out the materials to make pretty things from. And one of these were these brightly colored minerals, which initially, of course, would have been found on the surface of the ground, but invariably led to people digging holes to find more and better materials. And ultimately, because many of these brightly colored rocks and minerals are metal ores, they would have come across native metal under specific circumstances, which made that initial link between these brightly colored minerals on the one hand and this new natural material. Here's a lump of native copper. This is the sort of thing that people would have discovered when they were looking for things like this. This is a lump of malachite. which is a copper carbonate ore. And in certain circumstances, within the veins where the copper carbonate was found, you would get these nodules of native copper, which is a magical
That's
material.
copper, which is actually a metal in itself already, without us doing anything to it.
Exactly. And then people would have experimented, a very sort of, I suppose, natural tendency to play around with these things. And of course, to people at that period, in fact, right across time, one of the major things, one of the major transformative forces that people knew about was heat, was fire. And if you apply heat to stone, then it improves the working properties of stone. So it would have been a natural desire to, okay, we know that this heat will make our lithic technology better. Well, let's try it on this newfangled stuff that we found alongside the brightly coloured rocks and minerals.
But first of all, if you try that with sort of copper, it goes sort of black, doesn't it? It's sort of, you'd sort of be ruining your beads by doing it.
But it also makes the copper easier to work as well. It makes it more malleable. And of course, ultimately, if you apply a lot of heat, too much heat, arguably, then the copper will melt. And in the liquid form, it allows you to potentially cast different shapes and do all sorts of other wonderful technological things with this material. So I think that's the kind of trend we see through the archaeological record, is a period of experimentation, this link with brightly coloured rocks and minerals, and a period of experimentation, playing around with small bits of copper. The main sea change after that, of course, is the development, the knowledge that you could actually turn these brightly coloured rocks and minerals into metal through the application of heat.
It's always struck me that when you're working with beads and you've got all that powdered malachite as well, there's that effect which I was trying to kind of demonstrate a little bit, maybe too dramatically in the videos, that you actually end up encountering some amazing immediate changes in materials. So you're putting accidentally or on purpose, probably at least initially accidentally, maybe, as you're working your bead, you're grinding away, and suddenly notice that as you're grinding, some of that dust is floating into your fire, and it's turning your fire weird colors. I mean, I always thought, it struck me, sort of the more I've done sort of practical activities to do with metallurgy, that must have been quite a strong driving force, because it is enormous fun. I mean, it's a bizarrely sort of exciting thing to do, even in a modern world where we have, you know, everything we could imagine in terms of, like, you know, shiny screens to look at. It's still quite extraordinary to be able to change color. Alan, yeah.
No, I was just saying, it's like Bronze Age fireworks, isn't it? It's, people get pleasure out of it.
Yeah, exactly.
All these.
Yeah, I think the role of colour is tremendously important in the development of humankind in general, but certainly specifically with regard to developments of metallurgy, because colour changes and knowing what is happening, what physical changes are happening when the flames turn a certain colour, I think is a central way of monitoring any pyrotechnological process.
Absolutely.
So I think that because if you consider, I suppose, we're very much sort of today governed by the language of science. We understand these processes in so much detail, and there is a whole literature of science and a whole nomenclature of science. But if you imagine a world without any of that, what do you look for? How do you tell when your piece of metal is hot enough? How do you tell where your furnace has got to the right temperature? What are the things? How do you judge this? You don't have a thermocouple to put into the furnace to measure the temperature, but what you can see is changes, perhaps ever so subtle changes, in the color of the flame. And I think that ability to observe the natural world is something which our forebears were very acutely attuned to.
Absolutely, and
it's not just the color of flames. Metal. Sorry, Alan, you were going to say something there.
I was going to say, you were talking about the malachite going black if you just put a flame on it. But if you cover it over, keep the oxygen down, and you observe the flame color as Matthew's saying, you can tell the temperature of the flame, although they wouldn't know what that temperature meant, and they could also tell you if there's less of oxygen equivalent, whatever they thought that was, to actually turn it from black to metal. So
I suppose it just.
I mean, it is amazing how quickly it will just turn to metal.
Sorry,
it goes that beautiful salmony colour, doesn't it?
Peter, so.
It's not, but it's not just these sort of the ores themselves or the flames which change the colour. People are playing around as well as they sort of begin to explore different types of metals and kind of encounter different types of ores. They're encountering ores which are presumably producing different coloured metals, as they're ores which have different.
The other thing I've mentioned is smell. Because if you, for instance, had arsenic in your copper, you're going to get garlic smell. So, and it also kills you as well, but that's by the by if you do it long enough. But it's obviously, all the senses. We have technical terms to describe them, but through trial and playing error, they would find the right combination of color, time, smell.
Exactly.
Rocks, etc.
People were using this as well until really recently, weren't they? In industrial professions, looking at managing large-scale processes. A lot of that was being done by eye until well into the 20th century.
Well, it used in glass making as well, which I used to work in. Yes.
Was that true? Is that true?
Yeah,
true in that process?
The guy that was putting the batch for making glass into the furnace was called a teaser. And he basically teased things just right by all his experience and etc. So it's all about craft, isn't it? What a lot of craft people today have skills that they can't put into words. They just have that craft from years of experience.
Yeah,
fascinating.
Yeah, and there's a lot of ethnographic evidence about this, which shows how so-called traditional societies. Up until the present day, they actually they operate in a world without the language of science. They gather a huge amount of knowledge, which is passed from generation to generation in a series of almost like folk tales. And of course, it
gives the opportunity for lots of kind of stories to be bound up in technology.
And the things that are noted are things like colour and smell. Those things which human senses, our own senses, can detect without the need for fancy scientific instrumentation.
Oh, Jake, you're muted.
Yeah, Jake, you're muted.
Sorry.
Yeah, it happens all the time, don't worry.
Following on from this discussion about skill sets and craft and stuff, I think something that's definitely prevalent in metallurgy is that, when it was first discovered, you had this new shiny material, and over the years, people learned how to manipulate it. First, make simple tools, but then as we see in the wealth of artifacts that we have across the years, metals were used in all sorts of things. You have coins, you've got vessels, even mirrors and stuff, which Liz works on. And some of what we can see when we analyze these is that as people improved their craft, they were actually then playing with the metals and experimenting and making different combinations, and that would obviously change the properties of the metals, make it easier to work with, or if you needed something more solid, harder, you could mix in a different metal for that. I know that Liz, your mirrors that you look on is arsenical copper, isn't it?
Most of them are earlier on. I have looked at some tin bronzes later on in Egypt, but primarily arsenical coppers. Yes, so the more arsenic you add, the harder the metal gets. But also it changes the color of the metal. So pure copper, quite orangey, and then more arsenic, you'll go between golden to then eventually silver. And obviously to do with mirrors, to do with how you would have seen yourself in the reflection, that color would have been important. You got a golden looking mirror, your reflection is going to be a lot more yellow, whereas if it's silver, it's going to be whiter or more true, is how you view it now with our glass and all of that. And then also what I found is they were manipulating the arsenical copper to imitate possibly other metals. So specifically in ancient Egypt, silver was actually more valuable than gold. So an arsenic turns the metal silver. So we think they were manipulating that to create these silver surfaces, so they would have looked more expensive, say, than they actually were, to look more like actual silver than them being just arsenical coppers.
And people do that with coins as well, don't they? Trying to cheat people into thinking it's more valuable than it is.
Well, I think
Yeah,
since the inception of metallurgy, people have been developing ways to make things appear other than they are. I think the earliest archaeological example we have of a definite cheat going on is was way back in the Chalcolithic period in the Levant, and there's a small group of gold alloy bracelets that were discovered in a cave in what's now Israel. And when they studied these, they found that actually they were of quite a mixed alloy of gold and copper, but the very surface had been treated in such a way as to produce a very thin layer of pure gold. I say this is Chalcolithic period. This is about 4000 BC, not that long after metallurgy itself developed. So it's as soon as people were doing this on any sort of level of scale, they were developing ways of basically fooling each other. And certainly when you come to the advent of coinage in the first millennium BC, the earliest coin forgeries are forgeries of the very earliest coins.
I think it actually brings us to, there's a question in the chat about where the first metal smelting in the world took place. I think, as I remember, it's Serbia, I think, is the earliest dated evidence in Bjelovar, which is about, is it 7,000 before now? So 5,000 BC.
5,000, just over 5,000 BC, isn't it?
Yeah.
Yes,
and
it's about 50 years earlier than the previously earlier site, which was in Israel at Timnah. It's a very competitive field, I think, in archaeology in general, to have the earliest metallurgical site. Sorry, Alan.
I was going to say, yeah, Israel's, and then Serbia's got the big claim at the moment, and then Anatolia as well had some very early stuff. So it was all, and there's a big debate as to whether it was all because of all the complexities of doing it well on any sort of scale, that it could have been invented in one place and then diffused to other countries. But then there's other scholars believe that there was a lot of independent invention going on. Or you might even say it was invented loads of times, but you had to have the right structure in society for it to survive. So
you have that the right background, the right sort of background. When people are willing to accept these ideas. I spent a long time looking at early pottery, which I won't talk about now because it's about metals. But it's something where you have exactly the same thing. This competitiveness over the earliest examples of it. And it's really interesting. I've always found it really exciting to look at that moment afterwards when people are really spreading out and exploring this technology and kind of taking it in new directions. And it's something Matthew said at the beginning, actually thinking about, like, people developing metallurgy really actively when they're settled societies. I mean, I've been working for many years with mobile peoples in the steppe zone of Eurasia, who are absolutely responsible for spreading this technology across pretty much the whole width of Eurasia. It starts in these kind of local areas, Anatolia, the Mediterranean, provincial corner, and out across the entire rest of the steppe. You have this big explosion of metallurgy. It's sort of where people are really carrying technologies with them, and you can see that those processes of connection between areas really sort of building up over time. So there's loads of exciting things to talk about in terms of trade and exchange. And it's actually something that you've been working on a lot, isn't it, Alan? You've been working on sort of how we use metals in these ways to look at patterns of trade and exchange over time.
Yeah. So many of you might have heard about DNA and all the revolution that's bringing about in archaeology to show the movement of people across from the steppes, as Peter mentioned, right across Europe and then into Britain with the first metallurgy around 2,500 years BC. But you can also use material culture, the movement of metals themselves, to actually tell us something about these times where we have no documentation, to give us some pieces of the jigsaw as to what people were doing, where people were moving to. And the project that I did for my PhD was all about the copper from the Great Orme Bronze Age copper mine on the North Wales coast, not far from here, which you can go and visit. And that was one of the biggest copper mines in the Bronze Age in Europe. And there was a period that the research has shown, by using the latest chemical technology and the latest isotope technology, to fingerprint the metal from that mine. And then if we analyze lots of metal from Britain and over Europe, we can see which of these metals, objects, were made from metal that came from a particular mine, in this case, the Great Orme mine. And that allowed me to actually construct this map you can see in the top here, where the red dots are metal from the Great Orme. So you can see that tracing the metal with its fingerprint, we can trace the metal from the Great Orme in North Wales to Brittany right up to Sweden. So we can do exciting things and add to the story that the DNA gives us. We can get it from this sort of project. So metal has all sorts of uses besides its visual spectacular nature.
Yeah, and one of its kind of really interesting properties as well, I think, is things like sort of thinking about, when you were talking about the movement and trade of material, it's really exciting to think as well about how people are bringing together their materials and sort of reworking them. And this is the beginning of sort of that, of recycling, isn't it, as well? So we've got this the first time we have a material which we can actually genuinely reuse. If you look at stone, you hit it with a hammer again, it gets smaller. If you look at wood, you can maybe reshape it into something else, but there's not much you can do about it. Metal,
that's right.
You can do it again and again.
Infinitely recyclable, apart from what you might wear away, and that sometimes complicates our studies if you've got lots of different sources coming together, and if it's not just all coming from one big mine. But no, I think that's something that's not new, and it's very interesting on archaeological sites. Normally, on archaeological sites in Britain, you don't find, or anywhere else for that matter, you don't find much metal on the archaeological site, and it's only because it used to be taken away, recycled, or reused. Whereas where we had the British Pompeii and Mist Farm in Norfolk, there we had the settlement burnt down, and all the metalwork that was in the settlement was trapped. And that for the first time in this exciting new site that you may have seen on various programs, that they know now how much metal was in each household. And so we can get a feel for how much metal was in the Bronze Age world in Britain, whereas normally it's hidden due to the recycling that Peter's mentioned.
That's so exciting, isn't it? I mean, if you haven't had a chance to see or look at the material which was found at Must Farm, it's one of the most amazing sites that I've ever seen in my life. I mean, it was just really a real privilege to be able to visit it and to see like this, just as Alan says, entire houses just burnt in the place where they were, with everything deposited, everything from wagon wheels to metal objects and bowls, and just extraordinary.
And the other place we find trapped in time is shipwrecks, and we've got quite a few of these in the Mediterranean, with quite famous ones. But there's one off the Devon coast at Salcombe, where they found over 240 odd copper ingots, and also here on this side they found 40 tin ingots, thought to be from tin from Cornwall, which is very rare metal. And it's the only place in Britain that it's found. And the shipwreck, there was none of the wood or the ship left, just the metal which survived. And that's giving us clues about the movement of metal. So suggesting in the late Bronze Age, mid-late Bronze Age, there was movement of quite large cargoes of metals across from Britain to the continent. And maybe the tin particularly, which is needed to make bronze, that may have been moving from Britain to right across Europe, possibly, and even to the Mediterranean at an early stage. And that's a project that we're actually working on at the moment.
There's so much to talk about. We've got a question in the chat actually from Kim, who says, "What's your favourite metallic artifact that you found on a dig or seen in a museum?" Liz, what I'm going to guess it's a mirror, but that may be misjudging you.
Oh, that is quite difficult. Well, yeah, obviously I do like the look of mirrors. So there is a mirror that's actually made of silver. So it's not like one that to look like it's actually, and there's only one example from Egypt. So it's quite.
Where's that been kept?
Ooh, I can't remember.
Oh no, I put you in the spot there. That was mean.
Ooh, yeah, no, I'm not sure what museum, but yeah, it was owned by a princess, which explains a lot. So she had access to it's silver.
Really good evidence that people, as you said, are playing with those metal colors to kind of to choose the ones they're interested. That's great. Mine is also silver. Mine is it's a small plaque in the shape of a bear with his little front paws tucked up underneath his face like this, which is from the early first millennium AD from near Perm in Russia. Beautiful thing. Maybe I'll find a way to post it on the chats, as they're extraordinary. What are your guys' favorite metal objects?
Well, mine is we know the Mole Cape made of gold. I mean, that's fantastic and in the British Museum. And but the other one not far away is the Karguli boat, which is made of a sort of slate material, and it's got metal laid on top of it. So it's the shape of a boat. It's got gold shields along the side of it, and the gold is actually put on top of tin. So it's a combination of material object with tin and gold, and forming a boat, which is signifying the movement of people and materials in the Bronze Age. So
fantastic.
A combination object of great interest.
How about you, Matthew?
I thought you were going to ask me finally as well. I was racking my brain while you lot were cleverly plucking individual artifacts out of the ether here. There are so many. I think this is the problem. I mean, I can't really sort of pin it down to one individual metal object. I suppose in terms of categories, then I suppose the things that strike me are things like the Nahal Mishmar hoard from Israel, which is this very, very early Chalcolithic hoard of metalwork, and how it's comprised of quite a large number of different artifacts types, but they split into utilitarian tools and very much ritual items, decorative ritual items, and both categories are made of very, very different metals. So it shows that even at such early times, they were being very selective in the sorts of metal they use for different types of artifacts, which was partially something that was predicated on function, but very much not something that immediately springs to the modern mind, and that we're talking about a selection process. We're very much situated in the attitudes of the time. And I think this is one of the areas where archaeometallurgy can really enlighten the past, trying to understand the way people use metals in different ways and the techniques that they develop to either transform the ore into the metal or the metal into the artifact. So I'm sitting on the fence there in terms of my most favourite artifact. But I think certainly the Nahal Mishmar hoard in general is up there for me.
Well, I found where the mirror's from.
Oh, right, Liz.
It's from the Met Museum in New York.
Ah, yeah, okay, yeah.
Yeah,
Amazing.
I've got a picture of it, but I don't know how I'd share it.
No, we'll maybe pop it up onto the web page for the department which we have associated with this. Well, just to kind of bring it together, I was thinking about like all of that study of metallurgy, thinking about the way in which we're studying the composition of metals. Actually, one of the things which, when we were preparing this, really struck me quite strongly was that initial kind of engagement with fire, where you might see changes in color as you're putting ores next to fires, or putting ores in the fire, perhaps by accident or on purpose. Actually, it is exactly the same technique which we're using at the University of Liverpool to actually study the composition of the metals now. We're exciting just as those little powdered fragments of malachite were actually becoming sort of excited as sort of their electrons are moving around and giving off light. Actually, that's exactly the same technique that we actually use inside a slightly more expensive instrument, maybe than a bonfire, to actually study the composition of the metals that we're actually looking at and understand all these patterns. So, if you have any questions, stick them in the chat, stick them in the comments of the videos if you have a chance to watch them. Other than that, we'll answer them online when we see them. If you want to contact me, my email's there in the chat as well. Feel free to drop me a line. Otherwise, have a very good light night. Enjoy the rest of the festival. There's lots of stuff going on, and we hope to see you at some live event in the future. All right, bye for now.